So which elements will form ionic bonds? This is very visual and it is really easy to keep up with. I'm going to take my green highlighter and I'm going to color code this. And I'm going to include beryllium in there, but he can sometimes do covalent bond. He's kind of funny. All of these guys, all the way down, all those guys, and that. That's one of those elements combined with one of, you don't really have the noble gases in there. They just don't tend to do it that much. One of those guys, that is an ionic bond. So it could be this one and this one. It could be this one and this one. It could be this one and this one, or something like that. Those form ionic bonds. So it's really easy to keep up with. Just think of this line as being the dividing line on the chart. So if you don't remember, these green things are the metals. So it forms between a metal, that's the green, and a non-metal, and that's the blue. So with the ionic bonds, first the electrons are transferred. Once the cations and anions, because it's positive, negative, it has to be a cation, which is your positive, your anion is your negative, are formed. Now this is a funny word, electrostatic. Honestly, that just means like the magnetic attraction between a cation and an anion is easily understood, because you know the positive and negative things attract. But it's also known as Coulomb's law. So Coulomb builds on that idea of that positive and negative attraction. It states that that attraction between those elements, and the attraction is what forms the bond, depends on the amount of charge the ion contains, as well as their distance apart. And of course that makes sense too. You know that magnets, when they're like really far apart, they don't have much interaction. You squish them close together and then all of a sudden they start to notice each other and they start to pull towards each other. And of course you know that there are some magnets that are much stronger than other magnets. Same kind of an idea. So more charge, you know, if there's a lot of charge involved, then it's going to have a stronger pull. They combine in the simplest ratios that allow the overall charge to be neutral. We'll be practicing this also. So we call the bonded cation and anion a salt. That's one name that you can call it. You can also call a bonded cation and anion a formula unit. Let me change that to formula unit. That's like the smallest amount. So up here on this page right here, this would have been a formula unit. Just that smallest ratio of 1 to 1. Remember that compounds are made up of 1 mole of molecule equals the 6.022 times 10 to the 23rd formula units. You may want to make sure that you actually write this out and not abbreviate it for various reasons. Ionic compounds are also called salts. So generically we use salt at the table, that is NaCl, which was on the previous page. You probably already know that. Many ionic compounds are soluble in, well, what does NaCl dissolve in easily? Water. And they have high conductivity. Once dissolved in water, they conduct electricity. So NaCl, salt water, or salt or water with any kind of dissolved ions, because water comes with dissolved ions. In most cases, unless you have deionized water, which is not easy to just randomly buy. Once dissolved in water, they conduct electricity, but they don't do it when they're solids. They have to be dissolved in the water to do it. So even though we write them as one compound, they'll layer together in that lattice shape. So we'll write it as NaCl, but you want to remember that they kind of look like this picture here.